projects. In this video, we are going to explain about a project titled Feature Extraction for Classifying the Students based on their academic performance. As educational evolves, understanding the factors influencing the student achievements become essential for personalized support and targeted intervention. Leveraging the advanced data analysis and machine learning algorithms, our project aims to extract the relevant features from the student data and build a robust system for classifying the student into different academic performance categories. By delving into the correlations and applying the sophisticated algorithms like decision tree, SPM, random forest, Gaussian NB, voting classifier, and of many more, we seek to provide the valuable insight to the educators, policymakers, and stakeholders. This transformative endeavor holds the potential to optimize the educational strategy, allocating the resources efficiently, and foster a more inclusive learning environment that empowers the student towards the academic excellence and success. The objective of our project is to develop an efficient and accurate system for classifying the student into different academic performance categories through the advanced data analysis and the feature extraction technique. We aim to identify the key factors influencing the student achievements by employing a wide range of machine learning algorithms. We seek to build the robust model for the student classification. The project inside will provide the educators, policymakers, and educational institutions with valuable information for the personalized support, early intervention, and the academic planning. Ultimately, our goal is to enhance the learning experience, optimize the resource allocation, and foster a more inclusive educational environment that promotes the student success and well-being. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. The project begins by importing the essential Python libraries like NumPy, Pandas, Matplotlib, sklearn, Flask, etc. These libraries provide the necessary tools and functions for the data manipulation, visualization, machine learning, web development. The second one is importing the dataset. The student grades dataset is imported. This dataset contains the information about the academic performance, including their grades and other relevant features. It serves as a foundation for training and evaluating the machine learning model. And the third one is checking for the null values. The dataset is checked for any missing or null values. If present, appropriate handling technique such as imputation or removal are applied to ensure the data completeness. And the fourth one is checking for the correlation. Correlation between the different features are examined to identify the relationship that influence the student's academic performance. High correlation indicate the features that are redundant and highly related, which could be considered during the feature selection. And the next step is label encoding of the important categorical features. Categorical features that are crucial for the student classification are encoded into the numerical values using the label encoding. This conversion allows the categorical data to be used in the machine learning algorithms effectively. And the next step is feature selection. Feature selection techniques are employed to identify the most relevant and informative feature for the student classification. This step helps reduce the dimensionality and improves the model efficiency and interpretability. And the next step is algorithms used. The first one is decision tree classifier. Decision tree classifier is used to build a classification model based on the tree-like structure. It makes the decision by repeatedly splitting the dataset into the subsets based on the feature value, resulting in a tree with the leaf node representing the class label. And the second one is SPM. It stands for the Support Vector Mission, is a powerful supervised learning algorithm used for the binary and the multi-class classification task. It seems to find an optimal hyperplane that best separates the different classes, maximizing the margin between them. And the next one is random forest. Random forest is an ensemble method that combines the multiple decision tree to improve the classification accuracy and reduce the overfitting. And the next one is Gaussian NV. Gaussian NV is a probabilistic algorithm based on the Bayes theorem. It is well suited to the continuous features and assumes that each feature follows a Gaussian distribution. And the next one is voting classifier. Voting classifier is an ensemble method that combines the prediction of multiple classifiers, including the decision tree, SVM, random forest, Gaussian NV, logistic regression, KNN, ADA boost, and stacking classifier. The voting classifier takes a majority vote, and the most frequent class label is chosen as the final prediction. And the next one is logistic regression. Logistic regression is a linear classification algorithm used for binary and the multi-class classification tasks. It models the relationship between the features and the class probability. And the next one is KNN. KNN is a lazy learning algorithm that classifies the new instances based on the majority class of their k nearest neighbor in the training set. And the next one is ADA boost. ADA boost is known as adaptive boosting, is an algorithm that sequentially trains the weak learner and assigns the higher weight to the misclassified instance to build a strong classification model. And the next one is stacking classifier. Stacking classifier is an ensemble technique that combines the multiple classification models, including decision tree, SVM, random forest, Gaussian NV, logistic regression, KNN, and ADA boost. It learns to combine their prediction through the meta model, increasing the overall predictive performance. And the next step is training the model. Each algorithm is trained on the pre-processed dataset to learn the pattern and the relationship between the features and the student academic performance. And the next step is the user gives the input. A Flash web application is created to allow the user to input the relevant information for predicting the academic performance category. And the next step is the given input is pre-processed for prediction. The user provided input is pre-processed similarly to the training data, ensuring it is in the right format and condition for the model to process. And the next step is trained model is used for the prediction. Each trained machine learning model is used to predict the student academic performance category based on the pre-processed input. And the last one is final outcome is displayed. The prediction from all the models, including the voting classifier, are collected and the final outcome is displayed on the Flask web application. The user is informed about the predicted academic performance category, providing the valuable insight for the academic planning and the support. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of CSS, JavaScript, images, web fonts, and the bootstrap files within it. And the template folder containing of the HTML documents typically include of home, index, result, sign in, and sign up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the dataset is an CSV file which we used in this project. And the feature extraction for classifying the student based on their academic performance is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the model is a pickle file which likely contains the deep learning algorithm information, and these files can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the signup.db is a file related to the database that will be used to store the user information. And for the execution of the project, first we need to copy this code folder path. and then open the Anaconda prompt. Here we need to change the location of disk to F because our code folder is present in fdisk. Then write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command, that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntactic errors or logical issues within it. And then click on the enter button. After running the app.py file, the Flash framework will execute the host at the local address like this. And here we need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use Google Chrome. And then enter on the click button. Here it will be redirected to the sign up page containing of the title and sign up button. Click on the sign up button. It will redirect it to this page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password. And we need to fill the details of username as of admin and password too. And then click on the sign in button. Here it will redirect it to the index file where we need to enter some input details to predict the academic performance. I'm entering the A plus of 10 and the A of 8 and the A minus of 3 and the B plus of 3 and the B of 2 and the B minus of 1 and the C plus of 0 and the C of 2 and the C minus is of 0 and then D plus of 0 and the D of 1 and the D minus of 2 and F of 0 and W of 1. And then click on the submit button. Here the performance prediction has grades lower than expectation and he or she is having the difficulty in studying the course. In this way we can predict the performance of the person. And here by clicking on the refresh button, here we enter the other details too. I'm entering A plus of 10, A of 8, 9, A minus of 8 and B plus of 7 and the B of 0 and the B minus of 5 and the C plus of 6 and C of 3 and C minus of 2 and the D plus of 1 and the D of 0 and D minus of 0 and the F of 0 and the W of 0. And then click on the submit button. Here it predicted as of grades lower than expectation. In this way we can predict the performance. And in conclusion, our project on feature extraction for classifying the students based on the academic performance has successfully achieved its objective through the utilization of diverse machine learning classifiers including the decision tree, SVM, random forest, Gaussian NB, voting classifier, logistic regression, KNN, ADABOS and the stacking classifier. We have developed a robust system for the student classification. By extracting the relevant features and leveraging these algorithms, we can effectively group the student based on their academic performance. This project insight offered the valuable opportunity for the educators and the policy makers to identify struggling students, implement the targeted support and optimize the educational approaches, ultimately fostering a more inclusive and successful learning environment for all the students.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.